State in order the sequence of transformations that have occurred to y equals 1 divided by x to give the equation shown below. The first thing we need to do when we're determining the transformations that have occurred is to reintroduce the dashes on the x and y variables as shown. Next, what we want to do is rearrange this equation to resemble y equals 1 divided by x as much as possible. So to do that, we're going to start by subtracting 2 from both sides of the equation. So this gives us y dash minus 2 is equal to negative 1 divided by x dash minus 3. And next we can observe that in the most basic equation there's a 1 on the top line, but in our equation we've got negative 1. So we can times both sides of this equation by negative 1, and that will give us negative y dash plus 2 is equal to 1 divided by x dash minus 3. So that equation now resembles the y equals 1 divided by x as much as possible. And what we now need to do is equate the y and x parts. So all of this stuff is in the position of y, and the bit down the bottom here is in the position of x. So that means that we can generate two equations. One says that y equals negative y dash plus 2, and the other one is that x is equal to x dash minus 3. The next thing we do is we solve for the dash terms. So for the y equals equation, we're going to start by subtracting 2 from both sides, and that will give us y minus 2 is equal to negative y dash. Then we multiply both sides by negative 1, and that gives us y dash is equal to negative y plus 2. For the equation involving x, all we need to do is add 3 to both sides of the equation to get x dash by itself. So that gives x dash is equal to x plus 3. Finally, what we can do is we can put this back into our mapping notation to discover what transformations have occurred. So we know that x comma y have been mapped to, and for the x value it has become x plus 3, and for the y value we've got negative y plus 2, and they were found from the two equations here and here. So on the previous slide we found that x comma y mapped to x plus 3 and negative y plus 2. We can now use this information to determine the transformations that have occurred. So the first thing that's occurred is a reflection over the x-axis, and that has been caused by the negative y in our mapping notation and this negative 1 that appears in this position of the given equation. The next thing that's happened is the translations. So we have a translation of 3 units in the positive x direction, which is given by the x plus 3 in the mapping notation and the x minus 3 in the denominator of the given equation. There's also a translation of 2 units in the positive y direction, which is given by the plus 2 in the mapping notation and the plus 2 in this position in the given equation. So they are the transformations that have occurred to y equals 1 on x to give this equation of y1.